In this video, we're going to look at different types of chemical equations. The first type are molecular equations, and this is what we've been using for the most part this semester. We write the compounds as neutral compounds as if they were molecules. And what I mean by that is when we dissolve ionic compounds in water, like this nickel nitrate or the sodium hydroxide, we know that they don't stay together. And when ionic compounds dissolve in water, they dissociate. And so nickel nitrate isn't really a nickel nitrate unit. It's actually dissociated into nickel ions and nitrate ions. And so the difference between the molecular equations and the complete ionic equations is any ionic compound or an acid we write in its true dissociated form. So we know that the nickel and the nitrates don't stick together when they dissolve in water. It's more like what we see in the complete ionic equations. And so rather than having nickel nitrate units, we have nickel ions floating around and nitrate ions floating around. And the same thing for all the other aqueous ionic compounds and acids. Any solids, liquids, or gases, because they're not dissolved in water, these ionic compounds aren't dissociating, so we keep them together. So something like solid nickel 2 hydroxide stays together in the complete ionic equation. When I go to the net ionic equations, there are certain compounds or ions that aren't going to be involved in the chemical reaction. For example, if we look at our complete ionic equation, we see that we have 2 sodium ions on the reactant side, and we have an identical 2 sodium ions on the product side. And so we can sort of cancel these out. And so in the net ionic equation, we only show the species that are actually involved in the chemical reaction. The spectator ions, like the sodiums and the nitrates that appear in identical forms on both sides of the equation, we leave out. So let's take a look at a couple examples of going from molecular equations to complete ionic equations to net ionic equations. Okay, so in this case, we're asked to write the complete ionic equation given the following molecular equation. So the difference between these two is we're looking for ionic compounds and acids. Soluble ionic compounds and acids we're going to write as dissociated ions. So the first reactant we have potassium carbonate. It's aqueous, so it's going to dissociate. And we need to get the correct number of ions. So each formula unit of potassium carbonate is composed of 2 potassium ions and 1 carbonate ion. So when I write this in its dissociated form, I have 2 potassium ions and I have 1 carbonate ion. All right, our next reactant is calcium chloride. It's also ionic, also aqueous, so it's going to dissociate into, each formula unit is composed of 1 calcium ion and 2 chloride ions. So I'm going to write 1 calcium, 2 plus, and 2 chlorides. All right, so now we're finished with our reactants. So now we'll do the products. I have to do this on 2 lines because I'm running out of space here. All right, our first product is calcium carbonate. We see this is a solid, so it's not aqueous, so it's not going to dissociate. So we'll write that as a formula unit together. So because it's a solid, it doesn't dissociate, so we keep it together. And then finally, I have potassium chloride. It is aqueous. In my balanced chemical equation, I have 2 potassium chlorides. So this is going to result in 2 potassium ions and 2 chloride ions. All right, and we have our balanced complete ionic equation at this point. So let's go on and look at the next slide. All right, so now we have the same equation, but I want to know the net ionic equation. So the difference between the complete ionic equation and the net ionic equation is the complete ionic equation includes the spectator ions, right? So for example, I have 2K plus on the reactant side. I have an identical 2K plus on the product side. And the same thing with the chloride ions. Like about 2Cl minus and 2Cl minus. So these are what we call spectator ions. So when I go from the complete ionic equation, as I have here, to the net ionic equation, I'm not going to include the spectator ions. So the 2 potassiums will cancel out. The 2 chlorides will cancel out. And what I'm left with is the species that are actually involved in the chemical reaction. So the net ionic equation is the following. All right, and we're finished at this point. So let's look at one more example. All right, so again, I'm given a molecular equation and want to know what is the complete ionic equation. So any acids or ionic compounds, I'm going to dissociate. Anything solid, liquid, or gas, I'm going to keep together. So my first reactant is copper nitrate, and it's specifically copper 2 nitrate. So this is where knowing how to go from formulas to names is important, right? So I know each nitrate is -1. There are 2 of them, so this must be copper 2. So when I dissociate this guy, I'm going to have 3 copper 2 ions. And for the nitrates, right, each copper 2 nitrate formula unit has 2 nitrates, but in my balanced equation, I have 3 of them. So 3 times 2 is 6. So I'm going to have 6 nitrate ions. All right, sodium phosphate, also aqueous, also ionic, so I'm going to dissociate it. And just like the nitrate, I have, in each formula unit, I have 3 sodium ions, but because I have a 2 in the balanced chemical equation, I'm going to have 2 times 3, or 6 sodium ions. And then finally, I'm going to have 2 phosphates. All right, so we're done with our reactants. Now we'll look at the products. And so sodium nitrate is soluble. It's ionic, so I'll dissociate it. I'm going to have 6 sodiums and 6 nitrates. All right, and our final product is copper 2 phosphate. It's solid, so I'll keep it together. So my last product remains unchanged. All right, and this is our complete ionic equation. All right, finally, I have the same equation. I just have the complete ionic equation typed out here, and we want to now write the net ionic equation. So what I'm looking for is the spectator ions. So I have 6 nitrates and 6 nitrates, so that's a spectator ion. I can cancel those out. I have 6 sodiums and 6 sodiums. It's a spectator ion, so I'll cancel those out. And the coppers and the phosphates are not identical on both sides, so my net ionic equation is the following.